So I have not written the test yet. We just started. So any preference? Rational, radical, log, exponent.
Radical. Let's do radical.
Okay, let's do a radical. Okay, so here is, there are so many, I don't even know what to choose from. Many of them are not trivial. So 23. 317. Y equals the square root of x squared plus x minus 2. Okay. The first thing has to be domain. How do I start? What do I write in order to find the domain of such a function?
X squared plus x minus 2 is greater than 0.
Awesome. Which is x plus 2, x minus 1, greater than or equal to 0. This is a quadratic inequality. How do we solve a quadratic inequality? We have to study the sign. X plus 2, x minus 1. We've done this in pre-calc for this, actually. That's why we studied polynomial, quadratic, rational inequalities. X is the variable in the problem. Where is this expression 0? Perfect. When is this expression 0? These are the only numbers I need in the table. That's why I put them on the side, just to make sure I put them in the correct order. X plus 2 is 0 under. X minus 1 is 0 under. Good. So this is a product. Will be 0 when either one is 0. What is the sign of x plus 2? It's the same with the sign of x minus 1. They are linear functions with a positive slope. What is the sign? The sequence of signs. Does it come from positive?
Negative positive.
Exactly. Both of them have a positive leading coefficient. On the first subinterval, I'm multiplying two negatives. On the next subinterval, I only have one negative. And on the last one, I have no negatives. This will give us the domain such that the product is positive or 0. We haven't even started, and look how much work we needed just to find the domain. So the domain is that's it. So in the table, it's already a non-trivial situation. F prime, f of x, and f double prime. Negative infinity to negative 2, 1 to infinity. Please watch for a second. I didn't need to put it on the function. And I didn't need to give you any ideas just yet. I will come back to that. So all I wanted to show you is that there is nothing in between. That's all I needed to show just now. And then I'll come back. Okay. So the domain of this function, and this function will have two pieces. One piece between negative infinity and negative 2, and the other piece between 1 and infinity. Not connected, because there is a gap in between negative 2 and 1. Good. So I need to find this value here at negative 2, this value here at 1, and this. And where the function is 0. But I know that the function will be 0 when the quantity under the square root will be
2.
no.
What? Infinity.
So this function will be 0. So the square root of x squared plus x minus 2 will be 0 when x squared plus x minus 2 is 0.
Yeah.
And I just determined them right here and right here at -2 and 1. Is that correct? Okay, perfect. But yes, of course I want these two limits. So I want limit of f of x as x approaches infinity. What will that be? Of course. And what will be the limit of f of x as x approaches negative infinity? Very good. Do you all agree with that? So let's look at the function one more time. So the limit of this as x approaches infinity, these two don't count. They're too small. So infinity squared is infinity. When I take the square root, it's still infinity. When I plug in negative infinity squared is infinity. When I take the square root, it's still infinity. Would you agree? Perfect. So that's why those two limits are, and I'm done about, there is nothing else I can find about the function from the function itself. The x and y intercepts, I cannot plug in 0. 0 is not in the domain. I found the x-intercept. The y-intercept does not exist. And I found the limits. I'm done with the function. What is the next step? I have to find f prime. Yes. So let's find f prime. So f prime of x is 1 over 2 the square root of x squared plus x minus 2 multiplied by 2x plus 1. Will this function be undefined where the function is defined?
Yes.
Yes. At which points?
-2, 1.
Right. So that's why I jumped ahead by mistake. I wanted to show this.
Say that again.
Yes. This function is undefined when the function is defined at -2 and 1. This quantity is in the denominator now. It was not in the denominator initially. So this function is defined at -2 and 0 and 1. But this function is not, because its denominator will be undefined at -2 and 1. If the first derivative is undefined at -2, so will the second, obviously, and the subsequent one. So of course we don't need more. So the function is defined at -2 and 1. The derivative is not. The second derivative will not be. Okay. Now I need to study the sign here. See what happens there. There is no reason to discuss the sign of this and the sign of this. There is nothing there. Right? It's always positive. 2 is always positive. The square root will always be positive. The sign will be given by this quantity. Since it's a linear function with a positive slope, before -1/2, the sign will be
Negative.
and after -1/2,
Positive.
right, -1/2 is right here in the middle. So therefore, this is negative and this is positive. At this point, I have to make sure that these two rows work well together. Otherwise, there is an error somewhere. From infinity to 0, what does the function do?
Decrease.
Yes. Is this supported by the sign that we found? Okay. From 0 to infinity, what does the function do?
Increase.
Is this supported by the sign?
Oh, yes.
Yes. Okay. Okay. Now we are in trouble
Derivative of this.
because finding the second derivative will not be easy. Here's why it will not be easy for this function. So this is basically 1/2, which is fine. And this is 2x plus 1, which is fine. And this is x squared plus x minus 2 to -1/2. So I will have to use the product rule and then factor out and then solve in order to find and see if this function has an inflection point. Okay, So now, yes.
Before you did that, can you just cancel the twos? Because wouldn't it originally be 2x plus 1 over 2 square root of x squared plus x minus 2?
Yeah, but the 2x plus 1 is like.
Oh, you can't figure it out. My bad.
It's okay. That's okay. So let's take a look. Let's take a look. I know I only have 10 minutes or so. So let's take a look at it. It's, of course, a problem like this extensive work. I mean, it's going to take an hour on a test. So obviously I'm going to try to separate it or just have just a easier situation to look at. This is not possible in a test situation. It's way too long. Only this alone will take us a few minutes to find the second derivative. Factor is set equal to 0, whatever. So let's take a look. Of course, keep the 1/2 outside. Don't mess with it. It's not going to do anything. So let's see what happens. Maybe I'm just anticipating. I've never looked at this function. I just said, okay, let's take a look. So 2 times this to negative 1/2 and plus 2x plus 1 times negative 1/2 times x squared plus x minus 2 to negative 1/2 minus 1, which is negative 3/2. It may not be that bad. Okay, so I have to factor. If I don't factor, I will never be able to solve this. Yes, please. Allie?
Don't we have to multiply by the inside?
Oh, of course, I'm talking because I'm talking nonsense. Yes, of course. 2x plus 1. Thank you. Thank you very much. So now I have to check everything. So the first function prime times the second one plus the first function times negative 1/2 times our negative 3/2 times the inner function prime. Thank you very much. Okay. So now 1/2 outside, and I have to factor x squared plus x minus 2 to negative 3/2. Two is 2. Negative 1/2 minus 3/2, this is nice. It's 1, right? Negative 1/2 minus negative 3/2 will be 2 over 2. So x squared plus x minus 2 plus, actually minus. But I'm gonna, yeah, let me erase it because I don't want to have too many parentheses. But now what happens is, so I have a negative 1/2 in there. So I have 2x plus 1 squared because this is out. So then 1/2, 1 over the square root of x squared plus x minus 2 cubed. And let's see what we have here. 2x squared plus 2x minus 4 and minus 1/2. I have to square this. How many terms do I get? Thank you. 4x squared plus 4x plus 1. We're almost there. Not quite. So this is 1/2, 1 over the square root of x squared plus x minus 2 cubed. And 2x squared, doesn't look bad. Negative 2x squared minus 2x and minus 1/2. Not too bad. Because they cancel out. Yeah, that's really nice. Maybe they worked on the problem backwards. So 2x squared, yes.
Where'd you get the second 2x plus 1 from? Sorry,
Yes, it was my mistake because it's times the inner function prime, 2x plus 1.
oh, okay.
So I brought down negative 1/2.
Yeah.
I subtracted 1 from the power times the inner function prime. I was talking and
Okay.
no excuse. Okay, so I have negative 1/2 here, negative 1/2 here, and negative 1/2 here. So these two go away. These two go away. And after all this effort, what do we conclude? That there is no inflection point. It's just never going to be 0. So that's what I'm saying. So this is negative 4 and minus 1/2. So this is multiplied by what? 9/2. Correct. So after all this effort, that's why I highly recommend the second derivative, leave it at the end. Because obviously we didn't really need to do it. We really didn't need to study the sign. This is always negative, no matter what. Positive, 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 but there is a negative in there, so this will always be negative. No inflection points, and the function will always open downward. So then we are ready to graph. I only need a table. Everything is summarized in there, and the function is not symmetric. So I plot those 2 points, -2, 0, and 1, 0. Ready? From positive infinity, the function comes down to -2, 0, decreasing and opening downward. From 1, 0, the function is increasing towards infinity, opening downward. So this is f of x, the square root of x squared plus x minus 2. But we did determine everything by hand. We did look at the first derivative. We did look at the second derivative. Now we can check with the calculator if you want to, but there is guaranteed that this is the correct graph. Yes, it is a lot of work, but this shows that putting together the first and the second derivative, we can graph way more functions than we're able to graph in algebra, because we didn't have the information. We didn't know how to determine whether a function was increasing or decreasing. We didn't know about the first derivative. We didn't know about critical numbers. We didn't know when the first derivative changes sign, what that meant, max, min, depending on how it changes sign. We didn't know what the second derivative was telling us about the function. And it tells us whether the function is concave down or concave up. And we didn't know about inflection points. We didn't know when the function changes concavity, meaning when the second derivative is 0 and it changes sign. If it's 0 but it doesn't change sign, then that is not an inflection point. Any questions? Any questions? So I know I have 5 minutes left, so if you'd like, we can start a problem. Now, here in this chapter is where the indeterminate cases are, all 7 again. And this is in this chapter, that's why we already covered this part. L'Hopital's rule is addressed. So in 5 minutes, I think we should just look at a couple of examples, maybe at least one, with L'Hopital's rule, if that's okay. Okay. These problems are on page 308. Let's look at, yes, problem 21. You're going to like this one because, and you'll tell me why. I think you're going to like this one. And I'm sure you did not like it in chapter 2. Okay. So it's a ratio. When I plug in 1 at the top, I get good. And now in chapter 2, we were supposed to factor. So please factor this. Of course not. So we're not going to do that. Of course. Of course. So it's a ratio. It's 0 over 0. We are allowed to use L'Hopital's rule. So then limit as t approaches 1 from the top, which is
18 minus, or 18.
Very good. Over.
564.
Good. So of course I'm going to simplify 4 of these with 4 of these. And now all I have to do is just plug in 1. What do I get? That's it. So this is extremely useful. And we couldn't do this in chapter 1 because we didn't know what derivatives meant or what they were. Okay, let's look at one more and then we can stop. Yes, let's say 49. Last one, I promise. So limit as x approaches 1 from x over x minus 1 minus 1 over natural log x. Can I separate them and say it's limit of the first minus limit of the second? Never, because the limit of the first does not exist and the limit of the second does not exist. Right? So we cannot do that. We wish we could. So then the other option is, and the only option is, limit as x approaches 1 from x minus 1 times natural log x. And this needs to be multiplied by natural log x, and this needs to be multiplied by x minus 1. So x natural log x minus x plus 1. Now I plug in 0. I know I will probably not be able to finish in 1 minute. Plug in 1. So if I don't, we can continue it on Monday. So when I plug in 1, this is very good. This is negative 1 plus 1. So the numerator is 0. What about the denominator? Correct. So I'll let you finish it up. No, we're going to finish it together. I just, we're not going to be able to finish in, because this is the product rule and this is the product rule as well. So I don't want to hold you over.